Hello and welcome to the IoT Central Dev Board Roundtable. My name is David O'Hara and I am the Managing Director at IoT Central. Today's event will be an hour long and I'll introduce our hosts and panelists in just a moment. We'll be having a Q&A session after our panelists speak. You can submit questions in the control panel. IoT Central is a global community for IoT practitioners. Joining is free upon approval, and our content consists of member posts providing a rich peer-to-peer community. If you're not a member of IoT Central, I recommend visiting iotcentral.io to join. Now let me thank ARM as our host sponsor and panelists from Silicon Labs, Corvalent, Solid Run, and Avnet. From Silicon Labs, we have Miko Niemi, Senior Product Marketing Manager, Industrial IoT. From Solid Run, we have John Nettleton, Chief Systems Architect. From Corvalent, we have Alan Weiss, Industrial IoT Business Unit Manager. And from Avnet, we have Monica Houston, Technical Solutions Engineer. I'd like to introduce today's hosts. Alessandro Grande is the Ecosystem Manager, Automotive and IoT at ARM. He's a human-centric technologist who focuses on driving innovation by supporting a diverse range of developers building solutions in IoT, embedded, robotics, drones, machine learning, and security. During the last year, Alessandro has been focused on building a thriving online community of software developers. Robert Wolff is Manager, Ecosystem Developer Evangelist at ARM. He's a technical writer, open source evangelist, community leader, and studied engineer with a history of working in and around esteemed academic institutions and STEAM-based educational programs. He helps maintain several open source repositories, runs a global Discord server with thousands of developers, and moderates the ARM Software Dev Twitter.
Thank you, David, so much for the introduction.
Yeah, and on behalf of Robert and myself, I'm really excited to be here and to have the opportunity to actually host the second live stream on IoT Central. The first one was all about IoT and picking your dev board, and this is going deep in the space of industrial IoT. So I'm really excited for the chances to have 4 guests on today and talk to them about industrial IoT.
Awesome. So, Alessandro, it looks like we're ready to dive in here, but before we get to know our guests, I think it's important that we first talk about the landscape, painting the picture of industrial IoT from the bottom up. So if you wouldn't mind, let's start building that out now.
Yeah, so I mean, what's interesting, a big trend that we've seen in the past few years has been this trend of moving computation closer to the data, to where the actual data is being captured, where the sensors are, right? And it's really interesting because there was a lot of conversations about cloud computing in the last few years, and now we're seeing the computation actually moving closer to the edge, right? And there are some benefits of doing this, right? One of I always like to list 3 benefits for this for this trend, right? And reasons why you should think about it. The first one is really privacy and security. By operating on the data where the data is being captured, you avoid having to ship the data around, send it to the cloud, and sending back and forth information effectively. So that's the first one. The second one is power and cost. I always think that by basically not turning on your radio to send data away from the device, you can actually save power, and you could save costs by avoiding the cloud services to actually operate on your data. You can do all that computing on the edge itself. And what's interesting is that we'll talk about it today. With recent ARM technology, you can actually do way more processing than you used to be able to do in the past, and therefore you can actually take advantage of the devices itself. And the last one actually is the benefit of reliability. By not depending on the connectivity or on the connection with external services, you're not dependent on the connectivity potentially being kind of jumping or anything happening to your device, and you can just rely on the device actually operating on the data itself. And I think this is one of the biggest trends we're seeing, and I'd be really interested in hearing from our guests what they think about this trend of moving processing to the edge. And I know you want to speak about some other trends. So Robert, go on. All you.
All me. Awesome. Yeah, no, Alessandro, great points that you put forward there. I like to kind of go into a little bit of the history of things. So this is kind of another in the early days story from me, like I kind of did in the last episode of this webinar series. So in the early days, the development on ARM or Linux on ARM ecosystem was very fragmented, primarily focused on the mobile market. You have to imagine like silicon vendors, OEMs, ODMs, the people who are making the chips and the devices. They all pretty much are playing into the consumer market of that time, right? So much was changing, and those who could afford these devices were pretty much swapping them out regularly as new and more powerful devices became available, right? So to this point, there wasn't much going on with regards to software support, revisions, updates, like where you can hold onto your phone for an extended amount of time and every now and then you get an update to these. Devices were almost intended to be pretty much temporary. What if you don't want to throw away your device every couple of years? What if you want to build out a sensor network that will last for 10 plus years and you want to be able to send regular updates to continue improving the robustness of this network? This is kind of where people started thinking about this, and a company called Linaro was formed at this point, right? So this is a co-founding, ARM was kind of a co-founder of this company. Linaro, rumor has it, stands for Linux on ARM. So Linaro began kind of uniting these vendors under a common goal. We want to make sure that you're not wasting efforts or engineering efforts siloed in your companies, rather uniting these companies to work together on the things that is just kind of redundant across the chipsets, across the boards, and allowing the vendors themselves to focus on their secret sauce, the things that their chips do very specifically better or the best. So this led to long-term support for ARM chipsets and devices through upstream Linux. Now, this kind of started to set a precedence for a standardization across the stack as developers began to focus more on or focus on more than just the kernel. So this is when developers started looking at the boot layer, middleware, abstraction layers, and eventually hardware standardization. I'm not saying that everyone has to adopt a hardware standard, but you do kind of see it pretty predominantly in this market. So why am I telling you all of this? The IoT, the industrial IoT space, is very vast, but it's also very exposed to security threats. Think about the attack surface expanding from originally being locked behind these doors where all the servers are. Now it's on the factory floor. Now it's in the wide open, ready for any sort of mischievous acts to kind of attack them, right? So developers working together on these standards and making sure that we are maintaining a very secure and robust system is very important. So I'm personally very excited to hear from our guests today about their companies, their experience, the efforts they have around industrial IoT, as it is very rapidly evolving space. So that's my kind of evolution or look back at how did we get here kind of thing. And Alessandro, are we ready to go? I think we're good now.
Yeah, I think now that we've kind of shared with you our thoughts on some of the interesting trends and some of the movers and shakers in this space, we're ready to hear actually from the experts on industrial IoT. So let's bring on our first guest then, Mikko Niemi, Senior Product Manager at Silicon Labs. Welcome Mikko.
Thank you, Robert. Thank you, Alessandro. So let me just quickly get these slides up here, and we can get going. I think you guys brought up, really excellent points for the industrial IoT and some of the trends. So let's continue from there. So for those who doesn't know Silicon Labs, it's a fabless silicon semiconductor company. but we also produce, software and solutions. So we are not only focused on wireless, we also have a broad line of MCUs. We also have sensors that could be used in industrial IoT applications. Then obviously we provide wireless stacks. We have stacks for Zigbee, Bluetooth, Wi-Fi, all kinds of different stacks that can be leveraged in various different applications. In addition to the chips itself, we also have modules. You can get reference designs to help your design work, and lineup of tools, and the dev boards are obviously part of the tools that we're discussing today. So really, Silicon Labs is a front runner in this space, and industrial IoT is actually a big application space for us. We are heavily focused on it. We have a whole business unit working on industrial and commercial applications, such as the industrial automation, asset monitoring, tracking, predictive maintenance, power tools, wireless human machine interfaces for industrial IoTs, building automation, smart city applications, and even retail and commercial applications are part of the lineup that we have. So a lot of good stuff going on in the whole industrial IoT space. But today's topic was really about development tools. And the way we at Silicon Labs, we see the development tools is that we have different types of tools for different purposes. So if we start from the left here, the first one, the Explorer kit, it's really kind of like the entry-level product. You can expand it with third-party hardware. Then you move on to what we call the dev kit or the dev board, and that's basically then a single board development unit. You can develop applications on that board alone. And then finally, it's the Pro series of our products. It's much more modular. It's the richest feature set. You can see that there is some display there as well. And I will go through now all these lineups a little bit more in detail, so the audience can understand what they are, and then also I can discuss how they can be used in the industrial IoT. So we start with the Explorer kit, and this is basically the most recent addition to our lineup of development boards. And really the concept of this development kit is that you can go ahead and expand it with these different connector boards. So you can see that there's the microbus connectors, there's the Qweek connector. And these connectors are then decided, hey, I know that I need connectivity for my application, but I do need maybe it's like some sort of a motor control board, or you have like a 4 to 20 milliamp interface board or anything like that. So in essence, you can start building these sandwich type designs to quickly prototype an industrial IoT concept that you have in mind. It doesn't mean that this board cannot do very sophisticated feature sets, not at all, but it's really the intent is that you can now expand it more easily with your preferred boards and get those work in tandem. So we have stripped down all the necessary or not unnecessary features like sensors and things like that you will add up to the sandwich that you want to build. And if you need to further customize the board, you can definitely use the breadboard headers there to do that. So really this what this kit is for is if you have an industrial IoT product in mind, you need to add connectivity there. In this case, Bluetooth. You can get a very quick and inexpensive way to do that. So these kits are available from our web shop, and they start at $9.99 in dollars. So it's a very, very inexpensive investment to get into the world of Bluetooth. It is hosting the very latest BGM 220p module. So this here is our PCP module. So you can see that there is an antenna. There's everything is included there. So you don't need to worry about any of those kind of let's say RF design issues with this thing. So this is really kind of like the entry point product. But I think what is the key, very, very interesting product for industrial IoT is this one, Thunderbolt Sense 2. So as I mentioned, not only it has the connectivity, but it also has a very, very wide spectrum of different kind of sensors. So I think it would take all my time if I started to read all those sensors, what they do. But you can see that there are sensors for air quality, for example. So one of our FAEs, there is a podcast on Spotify if you want to hear him explain how he used this to kind of like create like a COVID air quality sensor. So that's, you know, perfectly doable with this thing and the prototype. The interesting thing about the accelerometer that is embedded on the board as well. So I have worked with our embedded AI machine learning partners, and we've done predictive maintenance demonstrations using this board alone. So basically, I think Alessandro mentioned the processing going all the way to the edge. Well, you cannot go further at edge than this thing, because this would be basically then the predictive maintenance, like a vibration and temperature sensor that can be used to detect those anomalies in engines and bearings and other rotating equipment. So really, it's possible to run really sophisticated AI machine learning algorithms here by leveraging our AI machine learning partners that have designed those algorithms to be capable of taking advantage of the ARM M series processors that are on these boards. There's also additional flash if you had to store things on this board. So really, what I want to kind of like leave you guys with is that the Thunderbolt Sense is an excellent platform for many types of industrial applications. The Hall effect sensor, for example, you could use that, for example, to detect like a door open or close for asset tracking purposes to detect tampering. The UV light sensor, package open sensor, is the package opened or not, and so forth and so forth. The gyroscope can be used if there's a tilt with the package during the transportation. So there's all kinds of ways in which you can leverage this board to develop a prototype. And because there's a coin cell battery holder, you just plug in a coin cell battery and you can run your applications. You don't have to care about wiring and stuff like that. So you can really easily make a prototype and development using this tool. Then finally, we have the wireless starter kit. So as I mentioned, this is the richest in terms of feature set, and it comes with these modular radio boards. So you can think of it like the motherboard is sort of like your base platform, and then you can apply these different radio boards on top of them and swap them. So if you had to develop a Bluetooth application, you could have a Bluetooth board, and then you can have a Zigbee board, or you can have or other types of like a sub-gig board as well. We do also sub-gig communications, so that's also one thing that you can add. You have a display that you can use for basically your application, trying to see things. And then some of the advanced features that you don't have on the other boards, really energy monitoring features, so you can really make sure that you can get to the lowest power levels of your design. There's a packet tracing port, so you can see how the packets are going through, especially important if you're developing anything with the mesh networking stuff, and so forth and so forth. So again, this one then builds it up to the little bit higher level. And I forgot to mention about the Thunderbolt. So the first one, the Explorer, was $9.99 in our web shop. Just add $10, you get to $19.99, and you get to the Thunderbolt. The wireless starter kit, that's a little bit more pricey. So you see starting prices around $99 and above. But again, it comes with a much richer feature set than for your development needs. So really, this could be like if you had an industrial gateway solution that you had to develop, this might be a good platform for you to start evaluating that technology. And these radio cards, for example, with the BGM220, which is the Bluetooth Blue Gecko module that we have, the radio boards are also done using our own reference design for that module. So you could basically see how that is being done in real life, and then copy that to your own design. So also other can benefits from that perspective as well. And I think that was all I had. I appreciate the opportunity to talk to the audience, and I'll be there at the Q&A session. So Robert and Alessandro, I think we are passing the baton to the next speaker, please.
Mikko, thank you so much. We already had a couple of questions from the audience, and actually I just wanted to take the opportunity to remind everyone that there is a question panel, and if you have any questions, we'll take them at the end of, there is going to be a Q&A section at the end, so we'll take them then. So keep your questions coming. We're keen to try and answer them all. So thank you, Mikko, again for your presentation here, and we'll see you in a short while. Thank you. Robert, take it away.
Thank you very much, Mikko, as well. We'll see you soon. And Alessandro, you beat me to it. I would remind everyone about the Q&A box. Yeah, please post your questions there. We're saving all of them for the guests, and we have them nice sectioned out, so post them there. All right, next person on the list, John Nettleton, who is a Chief System Architect for Solid Run. Definitely look forward to this one. John, are you there? Can we get your video up?
Yep, it's coming.
There he is. All right, cool. So yeah, the floor is yours. Thank you so much for joining us, and definitely look forward to this one.
Thanks a lot, Robert, Alessandro. Yeah, as you said, my name is John Nettleton, and I'm the Chief Systems Architect for Solid Run. If you're not familiar with Solid Run, we are headquartered down in Aku, Israel. We just changed offices, so I had to remember that myself. However, we do have a global presence from manufacturing over in the Philippines. We also do manufacturing in Israel, and then various developers and business associates in the EU, Japan, Canada. We've been around over a decade now, and our specialty is systems on a module and single board computers. However, we've expanded that over the last few years. And we've moved, and now we have a lot more that are network focused, and as well as a right to market lineup of gateways, edge gateways. The edge is very important for us, and it's something that we see a lot of business, and that's very applicable to the industrial IoT as well, since we see the edge for manufacturing being very important, especially from a securities aspect. Here's our edge lineup. You see we go from the small edge, which is what we would generally consider IoT. We have our middle lineup, which is networking and ARM servers. This is also where we've worked with ARM with the systems ready certification for one of our boards. We're hoping to carry that over with our smaller edge ones, focusing on the systems ready internet ready. So that should be pretty exciting to do over the next year. And then we have our basically ready to deploy gateway solutions, which are labeled under the SolidSense lineup. These are all based on COMs or SOMs. We focused very much on our Linux. However, we do have some Windows support and Android. We feel the lineup fills many niches. That's one of the things you'll find is we don't have very specific target markets for these. We make a very general board, and we get customers who will do the craziest things, just taking our SOM, building their own board, taking the whole solution, getting that ready and deploying it on the network for their own custom solution, their own custom products. Some of the things where they've already used our hardware in the industrial IoT space, we've worked with some robotics for manufacturing, where it's basically where they're using the microcontroller for our real-time operating system to do actually the fine-tuned, very precise movement of the arms, and then they use the bigger processors to process more of the data and the understanding going on around there. The Imex 8M lineup is very good for this, since they have the microcontroller built right into the system on a chip. It's very nice for these sorts of applications. Additionally, on our boards, what we're adding is a time of flight sensor. which will help with Industry 4.0. It's important for knowing distance and getting a spatial relationship. All this data will be fed into the neural network accelerators on the Imex 8M Plus, which is the newest board that we're putting out. But it's not really just specific to the new boards. One of our most popular chips are the Imex 6 still, and that's a very good gateway chip, and it's used and it's battle tested. It can be deployed in all sorts of places, and it's what's so great about it is it just works. You can plug it in. It's well supported in mainline Linux. So as was stated earlier, you don't have to worry about getting updates for 10 years or whatever. The software is already mature and it's already out there. And using that to connect to lots of other different modern technologies, mesh networking, as was stated earlier, as well as different sensor networks. It's still a very good SOM. But slowly we are seeing the Imex 8 series start to catch up and be deployed in those situations. Some of the places where our gateways are already being deployed and testing, we have one place where they're doing pipeline inspection. And again, this is all collecting the sensor data, processing it on the edge, and then getting it up to the cloud in the most data efficient format possible. And this is the same for monitoring and machine wearing. All these things we feel that if you can condense it down to the edge and minimize uplink and also the reliance on uplink just for security and safety that's needed in industrial IoT. You don't want your 5G network to go down or LTE, and then all of a sudden you have a dead industrial process going on. We feel a lot of the processing has to be right on the edge in order for it to be secure and safe and redundant. So here is a brief overview of our Imex lineup. The main ones we're focusing on now are the Mini and the Plus. The Mini is more of a general purpose one. We feel it's a very one-to-one update for our Imex 6 lineup, has a lot of the same features, video encoding and decoding, lots of connectivity with Wi-Fi and Bluetooth. The Imex 8M Plus bumps that up a little bit more by also adding a neural network accelerator that can be for running your inferencing right on the edge. It also has dual ISPs, which are great for connecting cameras to do that vision processing. And then on the other side, you'll see that we have the lineup of the boards, each one carrying different features. All of these are mix and matched. Our SOMs are carried between them, and they're all industrial rated. So they're ready to be deployed out in the factory floor. Another thing that we're focused on, which is very important for products in the industrial spaces, cases. They're going to be exposed to pretty harsh conditions. One of the ones that we're most famous for is our Qbox M. This is a great little unit. It's very small. It does have power over Ethernet built into it as an option. And so this is a device where you can literally run one cable to it, stick it in with a camera, USB camera connected to it, and start doing vision processing and inferencing right on the edge. And then a new product that we have coming out is our SolidSense N8 Compact, and this is based on the Nano processor. And this is what we're doing with this board is it has a lot of the industrial protocols that are needed beyond what's normally available. Of course, you'll see we do RS-485, CAN, power over Ethernet. With our SolidSense lineup, we also have a programmable 2.4 gigahertz radio, and that allows us we work with WirePass, so you can use WirePass's encrypted mesh network for gathering sensor data and uploading it, processing it, uploading it to the cloud. Again, they're programmable, so those same chips can run just a standard Bluetooth stack. And that's what we have going for it. We'll talk a little bit more in the Q&A. Thanks a lot.
John, awesome. Thank you so much for taking the time to give us this presentation. I want to just give a really quick comment here that came in through the question area. Solid run devices are superb, and the company really does a good job in providing support. So I think that that's awesome, and thank you for whoever wrote that. So
Yeah, thanks
on
a
to the
lot.
next. Yeah, there you go, John. Yeah, and there were a bunch of questions that came in too, so we'll take those in the Q&A time. But yeah,
Sounds
thank you
great.
so much. We'll see you then.
Cool. So I think we're ready
Everyone.
we're ready for Alan. Alan is Industrial IoT Business Unit Manager at Corvalent. Welcome.
How are you guys? It's a pleasure to be here. Thank you for
Good.
having me too as well.
Hello,
I
Alan.
appreciate it. So let's put this on full screen. Can you guys see my slides yet? Let's see.
Almost.
coming
Let's
up.
see.
How's that?
There
They're
they
up.
are.
Okay, very good. So Corvalent has actually been in business for 27 years. We started in Silicon Valley, where we moved about 12 years ago to a suburb of Austin called Cedar Park, Texas. Wonderful town. And we started doing industrial motherboards in Silicon Valley. We literally were the best provider for our customers there, but it was very expensive there. So I wanted to take a little bit different tact with you and show you guys various scenarios and various hardware options, but also software options also. So if I go ahead and look at our solutions overview, like other vendors here, we support edge single board computers. We have fully formed computers also as well, gateways and servers too. The difference is that we build to spec. So all of our customers specify with us, work with us interactively on the requirements. We don't really follow the commercial roadmaps with respect to microprocessors or controllers. We follow the embedded roadmaps. And what this means is both for Intel and for ARM. And what this means is we can assure very long longevity for our customers. One of the things that we do is we have our own software platform. It's a fantastic platform, battle tested. It is one of the few platforms out there that can execute 100% on the edge. It can execute on premises, or it can execute in a hybrid or a pure cloud also as well. Interesting use cases. We'll talk about fault tolerance as one of those too. As with our hardware, we built our business on bespoke or custom build to spec. Same with the software. So we built the software out to about an 85% level, and then we customize it for each customer. We don't believe in low code or no code, in the sense that our industrial customers expect us to deliver fully formed build to order and turnkey applications for them. And then sometimes part of the problem is that they can't find enough operational technology folks to do things. So we open up some unique business case models too. You can use our cloud, you can use your cloud. We have our own line of sensors, but I'm not going to tell Schlumberger you have to use my sensors. They have sensors, industrially rated, class 1, div 2, very, very expensive. So we have to be extremely agnostic about that also as well. So we interface with almost any sensor and have connectors that can emit data for 20 loop, Profibus, BACnet, Modbus, it goes on and on, CAN also. And then we're not experts in AI, but we have partnered up with a couple of companies around Austin. It turns out that the Department of Defense has funded a whole bunch of Austin companies for AI and ML. And so we're going to take advantage of that and use their expertise for those types of things. Usual applications for that is predictive and preventative maintenance, but there's others also as well. Our value proposition is a little bit different than the average bear. It's based on customization and it's based on longevity. So different applications require different processing loads, different communication loads. Alessandro had some very good ideas about why you want to push processing to the edge. I would add also it reduces latency and it improves reliability also as well. So we take great pains to work within the cost constraints of each customer, and we can even provide customized manufacturing here in Cedar Park. We've got a factory, but our real deal is longevity. And being an American company, we have to have a slogan, right? And the slogan is consistency, longevity, and reliability lead to peace of mind. Look, we don't sell the same stuff that Fry's sells. Oh, that's right. Fry's went out of business, didn't they? Sorry. Best Buy or Dell or HP or one of those. We provide products that are custom built, that are set it and forget it. Long life support, this is very important. We can literally build the same computer 10 or 15 years after you bought the first one. You say to yourself, why the heck would I want a 15-year-old computer? You're not thinking like a customer. The customer is worried about parts on the parts truck. The customer is worried about reliability. They're worried about making sure that the system that has been certified, possibly by the FDA, possibly by some other standards group, will continue working and they can replace a module. We just got a call from the Department of the Navy. Our computers are on the USS Gerald R. Ford, and they don't leave San Diego without us on board. Well, finally, a computer died after like 12 years. So the admiral phones us up, and he's nervous. And when the admiral is nervous, you've got a problem, and it becomes our problem. It's basically send us 3 more computers, and we went back and we could actually build the exact same thing. So that's copy exact. The culture that we have in our company is a little bit different than venture-backed startups. We take the long run. It's not that easy to get a job here at Corvalent, but then again, we don't fire or lay off either. During the COVID year, which was dreadful for everybody, we had no layoffs at all. And so in industrial IoT, you see a lot of companies come and go, get acquired, and change the focus, exit the business. We've been around for a very long time, and here's the statistic that I find to be fascinating. For 98 or 99% of our customers, we are their sole source. I'm going to let that sink in a little bit. We're their sole source, and we're talking about Raytheon, Boeing, Lockheed Martin, 17 or 18 oil companies, industrial companies, all sorts of enterprises, Medtronic, Stryker for medical equipment. So for 98 or 99% of them, we are their sole source. So that's how we sell. Here's an example of a use case that kind of shows the things that we can do in our philosophy, which is that there's always 3 or 4 levels to an IoT network. Over on the left-hand side, left to right across your radio dial, there's data acquisition, and there we're showing an oil and gas Christmas tree. And so there's sensors all over that thing. And then how do you get that information back to something? Because the fact is that there are very few sensors out there that have a radio. You've seen some examples here from my colleagues, but very few out in the field have that. They don't have a lot of processing power. So you got to send that back somehow to some other processing entity. In our world, that's an edge computer. And we support 3G, 4G, 5G, Wi-Fi, LoRa, Sigfox, NB-IoT, Cat-M-WAN. We support industrial Ethernet, CAN. I suppose if we hooked up tin cans and string, we could probably interface with the sensor also as well. Our edge computers support both Intel and ARM. We launched an Iot Imex 6-based product, both an SBC, a single board computer, and also even as a one-use server. And the function of the gateway is to do a few things. The first thing is, as I said, our enterprise software, Cat APM, can run completely on the edge computer. So if I'm out in Midland or Odessa, the internet's pretty good out there, actually. In fact, they're now running industrial Ethernet out to the well site. But if you're in Snyder or Post or Monahans, you haven't heard of those towns. Nobody's heard of those towns. The internet goes up and down a lot, right? So you've got to keep processing and make sure you don't miss a sensor reading. So we have that ability. We're one of only 5 or 6 platforms out there in the world that can do that. And then you got to get the information back to the back end, and we support both an on-premises server. Obviously, we would prefer that you bought ours, but we support any of them, and we also support your cloud of choice: Azure, AWS, Google's cloud, IBM hybrid cloud, our own cloud, and that's where the enterprise software runs. So it's a very interesting architecture. We believe that ultimately the edge will move from this section out to what we call the far edge, and the far edge will have things like Silicon Labs has and Solid Run, where they have integrated microcontrollers, they'll have radios, they'll have sensors all in one device. They'll be fairly expensive to start out, but eventually that will go downhill, and we see that happening in 3 to 5 years. So here's a use case also as well that you may not have thought of, and it's IoT asset tracking. This is actually the University of Pittsburgh Medical Center, and they have, I hope that you guys don't have experience with this, but they have workstations in their hospitals, these carts. And so the problem is the nurses will stick the carts into the broom closet, they will hide them, they'll take them down to radiology, which isn't good because they've got a computer on them, right? So these days, they not only want to know where is their workstation, both indoors and outdoors, but also they want to know, is the drawer open or closed in the cart? And they want to know this because the primary vector for opioid theft, for stealing narcotics in hospitals, it turns out it's a patient who gets discharged. Yay, that's a happy event. But all those extra pills that were in there, they suddenly get, well, it's called shrinkage or loss. I call it theft. And so it's very, very, very important to understand who's signed in. These often have computers on top of them or laptops, but inside the workstation is an ARM 32-bit processor that deals with opening and closing of drawers and location. Here's a use case which I'm proud of, and I call it IoT of the sky. I'm not sure I can trademark that, but it's drones. So it turns out that there's a problem in the Amazon, and that's fires. And so the Amazon itself won't burn without a lot of preparation. So that means that there's very organized efforts to burn the land, clear it, and then use it for farmland or companies or whatnot. Highly illegal. So we take drone input also as well. We're showing infrared there. We can do visual LiDAR and all that. And what's flying on the drone is an ARM 32-bit processor. Then we can connect with satellite links or with very large towers in the Amazon. We beam that information back to our back end, and then we apply our rules platform. We're searching for things like carbon monoxide, carbon dioxide. We're searching for fire and heat. We're searching for all sorts of things. So that's a very interesting application, which I thought I'd share with y'all. And don't be afraid of taking sensor information in from all kinds of sources. So I guess that's about it. That's what I have to talk about. I also will be joining y'all on the roundtable, and I look forward to your questions. Thanks.
Thank you, Alan. We already had quite a few questions for you as well, so we'll take them shortly. Thank you. Our next guest, Robert.
Yeah. I don't know how we're gonna get through all these questions. Like, there's so many good ones that are coming in. We're gonna have to like pick and choose the absolute ones. But yeah, cool. Monica, last but not least, here we go. Technical solutions engineer from Avnet. Welcome, Monica, to
Thanks.
the IoT Central webinar. Yeah, awesome. So you're up. What do you got for us today?
All right. Do you guys see my screen?
We do.
Okay, good.
We're seeing Monica, we're seeing presenters mode. You might want to
Oop,
switch it
that
around.
is not the right sound. Oh, okay. 3. Ta-da. Is it good now?
Yes, you're good.
Okay, excellent. Okay, cool. Yeah, I'm going to be talking about Maxboard. So I work for Avnet on our product and emerging technologies team. So Avnet is, you might know Avnet is a big distributor, but we also create our own products. And my team has been working on these NXP, Imex 8M mostly, and now our RT as well, based dev boards that are Raspberry Pi form factor. So first we've got the Maxboard. So we've got Maxboard, Maxboard Mini, Maxboard Nano, and Maxboard RT, and those are really easy to remember. Those are the names of the actual architectures from NXP. So our first one in Maxboard is the Imex 8M. So we've got quad core ARM Cortex A53, as well as the M7, I believe that's, and so this is great for all kinds of multimedia applications. It's running, it has 4K and HDMI. We also have MIPI CSI camera, as well as MIPI DSI display, and Avnet makes our own Maxboard compatible camera. That's an on-semi part. All the boards also have Wi-Fi and Bluetooth. And then we've got, the 40-pin Raspberry Pi Hat compatible expansion. Like, at Lenaro, it's way better to reuse designs and make things standardized. And so we're hoping to have more, like, people can use Pi hats with these and just take advantage of that awesome ecosystem that Raspberry Pi has created. So the Maxboard, we've got it. So NXP's Linux is the Yocto project. And then we've got this running Debian. So that's, a lot of people are really familiar with Debian. We also run Windows 10. My coworker, Josh Foster, made this really cool demo last year for CES of a smart crane application that is running on the Maxboard. So it's taking in sensor data, and there's a cool heads-up display that's running Windows 10 IoT Core. And then also Android 9. These all, except for the RT, they all run Android. Yeah, so lots of really cool industrial uses. My job, I enable machine learning on the boards. And so I'm really interested in stuff like I made a smart doorbell project, embedded vision, machine vision, also audio and voice. So this one is really a powerhouse for multimedia applications. And it's such a small form factor. So it's great for embedded vision stuff. And then the next, very similar board, Maxboard Mini, is the Imex 8M Mini architecture, which is just like the Imex 8M architecture, except it's clocked slightly faster. You can also see, so we have this HDMI 4K display here. Instead we have quad USB ports, USB 2.0 ports. So yeah, everything that Maxboard can do, Maxboard Mini can do slightly faster, slightly more power hungry. I actually did a really cool benchmarking project on Hackster.io. We have lots of our documentation there because Hackster is a subsidiary of Avnet. So yeah, actually the benchmarking project is both there and Element 14, which is also a subsidiary of Avnet. So lots of really cool documentation. But the benchmarking project, I benchmarked it against Google Coral, Raspberry Pi 4, Jetson Nano, and Maxboard Mini actually was one of the top contenders. It was faster on the image classification benchmark than the Jetson Nano was. So this is a great board. All industrial applications nowadays, it seems like trying to add some sort of AI machine learning piece. And so this is a great board for that, and a great board for vision as well. And as you can see, it runs everything except for Windows 10 IoT Core. But yeah. So the Nano is just released, so I'm really excited about this. It was released in February. And then RT was released also in February for pre-order. So Imex 8M Nano, slightly less, I believe it has 1 gigabyte of RAM instead of 2 gigs, but it has 4 onboard MEMS microphones and an onboard audio jack. So this is great for any kind of like machine learning, like you do consumer audio, wake word detection. You're making your, embedding your own version of Alexa into your product. This can do all of that, and it can do everything at the edge. So that's really exciting. And then finally, the most recent board. This is still not publicly available, but it's available for pre-order. It'll be released soon. This little guy is running, it's got the Imex 8M RT1170 architecture. So it is running real-time operating system. It's running free RTOS, and then Azure RTOS is being developed for it soon. And this guy also has this additional 18-pin connector here for analog. So it has CAN, it has an ADC, it has DAC. So you can do cool analog applications with this. Like, I think a really cool thing is like anomaly detection. We have, so Witekio is Avnet's software arm that's working on software for these guys, and there was a really cool application that was checking for anomaly detection using like washing machine vibrations. So that's a cool use. It also has, it has 2 Ethernet ports. One is gigabit, one is 100 megabit. But I think that'd be really interesting to create. I like to create a demo showing off the capabilities of that. So for like time-sensitive networking. This slide is just a comparison of all 4. It's a lot of text, but basically a wide variety of boards depending on your application. All the way from MaxBoard Mini, which is the fastest and the most power hungry, all the way down to the RT, which is just the 2 Cortex M7s, and the real-time operating system. And I also wanted to mention, so we have some accessories. So obviously it's Raspberry Pi Hat compatible, so there's the whole ecosystem. We really like the clickboards, and I know that Avnet has done some work developing libraries for the clickboard ecosystem. There's 800 plus different clickboards from Microelectronica, and they're awesome. There's also a LTE cellular hat using Swan. So this guy, the Monarch, runs the Monarch Go, and it can work in pretty much any country. And then we have our touch displays, and we have our custom camera modules, and of course also has USB, so it can run pretty much any webcam. USB webcam. And then also we have lots of example designs from like industrial stuff on the Element 14 website, which if that's a short link there, avnet.me/maxboard. You can see a lot of really cool example solutions. And then also to like the more fun stuff on Hackster. This is Hackster's product page for Maxboard. So not industrial, but there's a cool project we worked on recently that you know about, which is the Double Buddy. I did a ransom note letter finder. So that's the fun stuff. And then finally, we have all these design capabilities. So more than just the boards, you can of course always hire Avnet to build them into a product. We have the Witekio guys are amazing with their software design services, especially for machine learning. They're really experts in their field. Yeah, that's the Maxboard.
Awesome, Monica. I'm actually very excited to hear about the Maxboard RT with the analog connectors. I've seen people do some really amazing things. If you can get a direct line into like the DSP or something, you can actually do, hearing aids and stuff. And those are like super pricey devices that I feel are in need for some innovation there. So definitely interested to see what people end up doing with that Maxboard RT. So yeah, thank you so much. At this point, we're going to be transitioning over to the Q&A section. I'm told by our generous IoT Central hosts that we have until 9:15 Pacific time. So we have roughly about 20 minutes to go through some questions. That's going to put us over, of course. So, you know, feel free to check out the on-demand afterwards. Alessandro, are we bringing in our guests now? Back to you.
Yeah, let's bring everyone on. So please.
Hello,
Robert. Yeah.
Oh,
Do you want to
sorry.
take the first?
I lost you. I lost you for a second. Yes, I actually do want to take the first question here. Thank you. Sorry about that. So gosh, Alan, you got a whole bunch of questions here. And I'm gonna tack you first here. So this is about long-term support, and you know, you mentioned this long-term support. I'm a huge fan of this. You know, I you know, working in upstream Linux, all this kind of stuff, all caters towards this long-term support. This is a two-part question. It says, how long do you support devices out in the field? 15 to 30 years, question mark. And then the second part to this is, how do you manage customers having to finally swap out that hardware when they want to change it?
Alan, we can't hear you. I think you're on mute.
Yeah. Oh, sorry. Yeah. Doesn't say he's on mute. I think his audio maybe got switched up. Alan, if you want to check your audio real quick. Oh, nope, we still can't hear you.
Can you hear me okay now?
Oh yeah, we can hear you now.
Okay, I'm sorry. So the first thing is that we support copy exact and build to spec for 7, 10, or 15 years. We've only been around for 27 years, so we haven't had somebody ask us to support it for 30 years, but with any luck, that will happen actually. And what was the second question again? I'm sorry.
How do you manage customers having to finally swap out that hardware? So like, you know, you get to that 7, 10, or 15 year mark. How do you manage that? Those customers that finally want to swap that out, or what if they don't want to swap it out?
Then it just keeps on running, right? I mean, we've had computers that literally have not been rebooted for 10 years, and that's fairly impressive. The operating system, the environment is all standardized, it's stabilized, and then it's just forgotten. So we manage it well. Our customers know that when they pick up the phone and phone us, that they're very likely to be speaking to the person that they talked to 10 or 15 years ago. And we keep track of all of our accounts.
Yeah, and this kind of goes back to your point when you were talking earlier about kind of like that long-term employment with Corevalent. So that's cool.
Yeah, how can you possibly support customers long-term if there's constant turnover, right? I mean, our staff here really understands applications that our customers build, whether it's factory floor, naval, defense, medical, industrial control, monitoring. They really understand the customer's applications.
Awesome. All right, your turn, Alessandro. Thank you, Alan.
Cool.
So knock all these out.
Let's jump back to Mikko. So I think this is so there was a question directly from Richard Fall that we could probably generalize a little bit as well. So he's asking, so Richard is asking, how do these boards differ from off-the-shelf ESP32 modules, for instance? But I would say, you know, let's generalize that and say, how does this board that you showed here differ from off-the-shelf boards that are not perhaps like, you know, industrial grade, right? So maybe that's the more general question that we can answer, Mikko.
Yeah, so the boards that I presented are, you know, obviously we thought about the user experience. So the out-of-the-box experience, you bring up the board, you connect it with your computer, you have sample apps that you can run. So it's really thought through, like how can you get moving really quickly so that you don't have to be spending a lot of time, you know, downloading and configuring and those kind of things. So you can quite easily do those things. And as it comes to the industrial applications, so obviously there are, you know, generally available other boards. They tend to be, similar, but I would say that, what Silicon Labs, RF performance, for example, is very important for us. So we have people that know RF design very well. So we've optimized those boards so that you can get the best performance out of our chips. So yeah, there might be boards that use our chips or our competitors' chips, but they may not be optimized with the performance. So I think that's kind of like one of the differentiators is really the optimization of the performance of those boards.
Okay.
Sorry, go ahead.
No, I was just going to build on that perhaps a little bit. Can you perhaps share some insights on the industrial grade of the components and the chip itself?
Yeah. So generally, if you look at our chips, there is different kind of grades. I can't remember on top of my head which grade is being used on those boards, but usually the boards are including, let's say, the superset part that has the most features and the best performance ratings and those kind of things. So we do have industrial graded parts as well that goes all the way to 105, Celsius from -40. So like I said, that might be a differentiator as well. That those we have parts that can cover the whole range of the industrial temperature range, for example. So that's one definitely there.
Cool, thank you. Robert,
great.
You're next.
Yeah, no, I feel like a kid in a candy store picking out these questions here. I'm going to go with John next. So John, when you were talking about the SolidSense Edge Gateway, the question here from our guest or our viewer is, which OS is the SolidSense Gateway on? Does it support Balena OS? And can you share some more details about this and about that board?
Yeah, absolutely. So currently, SolidSense is based on a build of CIP, the Civil Infrastructure Project, because it is deployed for, or it's designed to be deployed for longevity, where it's a gateway collecting data from a bunch of different sensors. Out of the box, what we're doing is we are running actually Apache's management stack integrated with Mender.io for remote updates and management. However, that's the turnkey solution we're providing, and you can buy it and get it up and running. However, it can be bought as just an open board, and we've had customers who have taken it and used Azure, Greengrass, all sorts of various different cloud connected solutions. And yes, we are working currently with Balena, and we will have that available for all our boards within the next month or so.
Awesome. Balena is a good one to work with. David Tischler, cheers. But yeah, all right, Alessandro, you're up.
Cool. So Monica, a question for you. So recently we've actually had another opportunity to talk about Maxboard and some of the applications. I'm curious, actually, from your point of view, what are some of the most interesting ML applications that you've seen of customers wanting to use on these boards?
Let's see. So I know customers. So there's a server temperature monitor that is controlling a liquid cooling system that's using Maxboard. I'm not sure. There's an industrial chemical dispensing application. I'm not sure if that's using machine learning or not, but another cool use of Maxboard. Yeah.
Cool. And perhaps you can touch on some of the cool stuff that you've done. I know that you guys have done some examples.
Yeah, so we've done like a lot of fun examples using machine vision. I think the standard Maxboard is an amazing board for machine vision based on my benchmarks, and the Maxboard Mini as well. So we've done like a lot of, I've done a smart doorbell application that identifies who's at your door. I have done the ransom note was a OCR, optical character recognition application. So recognizing letters on a magazine and cutting them out. Then you saw our Dobble challenge, which was another, we built our own, my coworker mostly built this data set of Dobble cards and was able to play Dobble or spot it, a card game against you. So some fun stuff.
I love
but
that.
also
Awesome, yeah.
applicable, to fun stuff that could be applied to other machine vision projects that are more industrial.
And it's interesting to see, that you guys actually did some power analysis on these different boards, and it actually showed the power efficiency of the different cores compared to each other running ML workloads. So that was really interesting. And yeah, if you guys, for everyone not watching, there is an online episode of Innovation Coffee where you can see Monica and the rest of the team talking about that. Robert, you're up.
Yeah, so I want to go to Miko for this one, because I was exploring the Silicon Labs website, and I noticed you have a pretty robust developer area, like a developer section there. So I was just kind of hoping you could take like 15 or 30 seconds to just give how can you enable developers? Like what can developers go do in this section? What can they get out of it? And what would you like to see from developers in this kind of collaborative space that you guys have over on that website?
I think that's, Robert, is a great topic. So yeah, so we for example, what we provide is a huge repository of GitHub example code. So you can take the code and you can integrate that into your project, get your fast track your development there. There's tons of application nodes. We recently hosted a series of what we call the Tech Talks, which is like technical trainings given by our FAEs working on Bluetooth especially last year, and those are continuing this year. So really, taking the advantage of those resources that are available to you, and then there is a developer forum. So being active on the forum and bringing up development ideas and those kind of things. I can tell you that we have, we actually read those things and we take feedback from the forum as well. So it's not like a wasted effort in that respect at all. So it really is a way to engage with the company and with the products. I think there's a great opportunity to leverage those resources. There's a lot of thought put behind, and we have an ongoing project to digitalize all our documentation, make it more easily accessible, and found the answers to any technical problems you have. So I really encourage people to take a look at that one and really use those materials.
Great to hear. Yeah. So anyone watching, go check out Silicon Labs, the website, and check out their developer section. It's pretty cool.
Cool. So let's see. Let's go to Alan again. So we've got a bunch of questions. Let's see. Let me pick one of those. Okay. So which sensors have Covalent integrated in their gateway that leverage BIC net over IP?
So right now, I'm not sure that I understand the question. Can you ask it again?
So which sensors have Covalent integrated in their gateways that leverage BIC net over IP? I'm not actually sure what BIC net is.
They probably mean BACnet.
BAC net.
BACnet, yeah, that's a building automation standard actually as well. So there's a little bit of confusion. We don't integrate sensors with the gateway itself. The sensors are the sensors, and that way we can make sure that the sensing function is done at the lowest cost possible. That makes sense. The sensors then feed that information into the gateways, and we have plans to integrate sensors with MCUs and with radios, but right now that assumes that everything's a greenfield operation. And we work with a lot of brownfield also as well. A lot of companies that we work with want to take sensors. For example, at Covalent, we actually drink our own Kool-Aid. We monitor, let's see, air quality, humidity, temperature. We monitor carbon dioxide inside our building. So all of that's contained in a single sensor module that is costs about like $30. I mean, it's very inexpensive. And then they beam that information back to the gateways. The gateways, their function one of the functions of our edge computers is to reduce the amount of data that you have to store on the cloud, because cloud storage can add up and it can get very expensive. So what if you just wanted to just send the exceptions up to the cloud, for example, the red alerts, so we can filter and do things like that. But BACNet's used for building automation, and we don't integrate the sensor with the gateway itself. They're separate.
Okay, cool.
Now, aren't you sorry you asked that question?
Okay, so just want to be conscious of time here. We have roughly 4.5 minutes left. I want to do a rapid fire here. See if we can knock out as many questions as possible. All the guests on the call, let's try to get like these done in 30 seconds or less. First one, going to you, John. Could you tell us a little bit more about the efforts you? It's going to be a tough one to answer in 30 seconds. Can you tell us a little bit more about the efforts you have gone through in your path to ARM system ready certification, and how it's kind of worked with Solid Run and the Honeycomb workstation, those devices?
Yeah, well, that's a long story. I'll do as quick as possible. Basically, work with ARM and the developer community, learn ACPI, learn UFI, learn the standards, and then join the System Ready Steering Committee and help define the standards. So, and that's for all of them. And we're very appreciative and glad to work with ARM.
Awesome. Making
Cool.
hardware boring. Yeah, there you go.
I'll take the next one quick as well. Monica, is there any plans for Nb2 Iot Hat or 5G modules?
Nb2 Iot Hat. Oh, so we don't have 5G
module,
right.
Yeah.
We just have the LTE GPS module right now, I believe, with Squans. I'm actually not sure. There is another LTE hat that's coming. I'm not sure. Yeah.
Cool.
Okay.
Robert, next
Miko.
one.
Yeah, Miko. So for you, what are the challenges and opportunities of IoT that help developers in the startup industry? Wow, I'm sorry, I'm trying to read this one. So yeah, what are the challenges and opportunities of IoT that can help developers in a startup community or in a startup industry?
Yeah, so I think from the IoT perspective, is one of the opportunities is obviously kind of like the edge processing and bringing the value to the end devices more than just pushing the data to the cloud, because I think it also addresses one of the challenges that people don't always realize, that if you have few tens of sensors, yeah, passing all the data to the cloud and crunching the numbers there is easy. But once you start to scale, I think what Alan just said is basically you just need to send the exceptions. Otherwise, you will have a network congestions. You have all kinds of traffic issues that you will face. So really think through the strategy, and even if in the beginning it feels like passing everything to the cloud is easy and it's the fastest strategy, you might want to think that how do you then bring the edge into the picture as well.
Cool. I like that one. Very good. Yeah.
The next one for Alan. How do these devices relate to industrial PLC? Are they a substitute, or will they form a symbiosis with PLCs? I mean, I think this is an interesting question because industrial is it's all about PLCs. So yeah, I'm really curious about your answer on this.
So I'll go fast. I have a customer. They're an old line industrial machine company, and what they do is filling of bottles, right? So with either food grade or pharmaceuticals. Right now, a lot of their sensors that they have on these machines are analog. So they feed that back out to our edge computer that runs a soft PLC, and then we turn that into digital, and from there we can do anything. I think that there's going to be coexistence for a very, very, very long time, but I'm not seeing a lot of PLCs being sold that are purely analog now. I'm seeing a lot of software ones.
Thank you. Robert, you got another one ready?
Yes, ready. quick fire. Monica, what are the differences between the different flavors of Maxboard and how can developers pick the best one for the job? And I know you kind of went over this, but maybe you can kind of just give a quick overview one more time on that.
Yeah. All right. So we've got, I'll hold them up actually. This is a Maxboard. That's a mini. That's a Maxboard mini. This is the Maxboard. This guy has 4K HDMI, Imex 8M. So that's the quad core A53 clocked at 1.5 gigahertz. Mini is quad core A53 clocked at 1.8 gigahertz, and it has the 4 USB. Similarly, Nano has the quad USB, and then RT is the microcontroller. This guy also has the, just like Nano, it has the 4 microphone array and audio jack. So I would use Nano or RT for, depending if you need them, if you don't want to use full Linux or embedded Linux. RT is embedded Linux, obviously, real time. Or sorry, RT is real time Linux. That's what the RT stands for, I think. And so those for audio applications, these for multimedia applications. That's the basics.
Great. Awesome. Yeah, and you can go check all those out on Avnet, at Avnet, at Hackster, and Element 14. You have some cool stuff going on there. Cool. Last one, Alessandro. We're taking the last question here. Sorry, we have to stop this. We have to stop this train.
Okay, so John, perhaps a general question to help our audience here. So there, obviously, you can choose different architectures for the boards that you use in your IoT devices. You know, how would you go about choosing the right architecture for your job?
Well, that really can be determined by many different things. One of the pieces that we're trying to do, and what we talked about earlier with the systems ready, is to make booting as easy as possible. So we like to take that out of the equation, have a system ready boot, and then it's, what do you want to run on it? Some applications are only ARM32, and we still have the Imex 6 base boards, and they still have a lot of longevity left, still another 8 years, I believe, or longer. And the Imex 8M, there you're going to go 64-bit. And so when you have the options to run Android or Yocto or any other Linux variant you want, and then it's all about what you want to plug into it. And we have boards from 1 core and a gig of memory all the way up to our big board. The Honeycomb is 16 cores at 2.2 gigahertz and up to 64 gigabytes of memory. So all depends what you want to do.
Perfect, thank you. Right, I guess we're at the top of the session, and I really wanted to thank everyone, all the guests, all the viewers, and IoT Central for this opportunity. So thank you all. And Robert, you want to close? Robert, you're on mute.
Killed it. All right,
It was a great.
So it would have been so good. No, but yeah, I just want to echo the thanks to our guests. Thank you so much for showing up. Thank you to the viewers, everyone here. Thank you, IoT Central, for allowing us to host this. And if you did enjoy Alessandro and I as your hosts, we do host a live stream on the ARM Software Developers YouTube channel every week on Thursday. So go check us out over there as well. We look forward to doing a whole bunch more of these IoT Central webinars. So thank you so much. And that's back to the IoT Central team. So back to you. Thank you so much. Am I still muted?
Thank you, Robert and Alessandro. A special thank you to all 4 of our panelists. As a reminder, a recording of this roundtable will be available for viewing on iotcentral.io tomorrow. Be sure to look for more webinars and roundtables from IoT Central. This concludes today's roundtable. Thank you for attending.